Hello and welcome back to the channel. It's Mark from PowerSonic and Apprentice 101. This is a super interesting install. We've got a very difficult roof aspect to work on, one of the steepest we've ever encountered as installers. We've got Magic Mike with us as well, so Michael Stott has come down to give us some assistance, and Matty and Nathan are going to be here too. We've also got the team from Proteus and Modexsoft Electrical OM dropping in on this one because we were local to them. So that's going to be nice, but you'll see here we've got equipment up on the wall already. I'm going to take you through some of the install of this, look at how we approach testing it, both at an AC and a DC side as well. But before we get to all of that, if you are a consumer and you're looking for a solar PV or battery storage proposal, and you want someone who's going to look at what best serves your home and your needs, then please do get in touch. Our contact details are in the description of this video, and we can get things like this into your home in most applications. We're not turning down working on slate roofs, on terrace properties like some of the big energy retailers would do. So we are here to try and serve you as consumers as best as we can. But without further ado, let's get straight on with the video and we'll see what we've got here and how it came to be. So it's a little bit windy, but as you can see behind me, the guys are up on the roof just finishing off the solar array. We've got 12 Jinko 440s on this back roof here. It's 49-degree pitch, and it is a really challenging one. It was re-roofed about 10 years ago, I think, according to the customer. It looks in good condition, but it's an old building. There's some lumps and bumps in places you maybe wouldn't find in new build of today, but it is constructed to a far higher standard. We've got 6 Jinkos going on the side, again, 440 watts. These are all optimized with Tigo, so we can do the rapid shutdown and see at a panel modular level what is actually going on. The guys have worked incredibly hard on this one. It's a really difficult roof, and we'll talk a bit about that in a later clip within this video. But I hope this is going to come over clearly on the audio because it is super windy down here. Ironically, up on the roof, it's not too bad because it's coming from that way. We're expecting some sunshine imminently, so let's see what we're blessed with later on in this video. So we're largely set up on the wall. I thought I'd take you through it really quickly for what we've actually got and what it's kind of doing. We've shown videos of these being put together with time lapses before. This is really similar to what we always kind of do, possibly different components, so we might not be using a grow watt inverter, we might not be using a PV inverter at all, but similar. If you watch a lot of the content, this will look familiar. And you can see with the gateway, we'll always start with that. So for the minute, we've got the grid cables running down, the pop up our trunking, and just above here is our mains tails isolator. It's just above the garage door. I'll show you when we've got the garage door down making those terminations. I've not brought the tails back from the consumer unit yet because we haven't done the changeover, but they're ready to go in, and the consumer unit is just also up there above this garage door. We've got our final circuit in for the AIO and the PV. They're both HO7, flexible 6mm cables. The ends are ferruled, so we use ferrules without the boots on, so they're just plain ferrules on the end, and then they drop down into the trunking and run across and away. So we've got the isolator here for the AIO, and you can see in there with our Wago style lever connectors and our link cable back up to the gateway in green, and loads of wiring room in there, nice and simple. Point of isolation for the AIO. The PV isolator, it's got a few cables in it. I'll come back to why in a minute, because we've done something slightly different to what we normally do with that on this one. And then we've got our DC isolators here, some PV Ultra there. There's about 40 meters worth. It's a good old run to get up to the roof, 6mm, and we'll show you that route as and when we get to doing that. But basically the PV is going to come down in this trunking into the isolators. We'll separate it just above them here, where we've just got all our DC cables, and then they can run through and in. They then return back through the trunking into this enclosure where we've popped some SPDs in. Now these do have SPDs built in, however with this array across 2 aspects and it's a very high roof, we thought we would pop some in just for belts and braces on this one to cover that off as well. And we're also going to pop the Tigo Connect system in here as well. So the little router's going to live in here, its little power supply and its cables in is all ready to go. We had started taking those feeds from the consumer units when we've been doing these, but we've done it a bit different on this one. So my phone was ringing, sorry about that. Yeah, we would normally take a circuit from the consumer unit to here. So the thinking was if someone turns the consumer unit off, that will shut these down, and that will then stop the DC coming off from the roof. However, you know, we thought in the gateway side of things, that would still keep power to the inverter, and it could be a situation where there's 2 consumer units and it's something that the customers done for whatever purpose and shut their array down when maybe they didn't want to. So what we've done is we've taken the power supply for the Tigo Connect in 6mm HO7 from this 63 amp rotary isolator and come up into this enclosure. So now if somebody turns the PV rotary isolator off to shut the inverter down, it will turn the power off at the roof in the strings on the DC side. The same will still happen if somebody comes into here and shuts all these off, so a firefighter or whatever who's coming in, turning power off into the house, all the other bits and pieces, that will still isolate the power in here and shut all that down. Equally, if somebody pulls the main service fuse and then turns the battery system off, it would still all shut down as it should and stop the DC cabling being live through the building, which is kind of what we want in those emergency first responder circumstances. It's really difficult with a battery storage system if somebody hasn't got the knowledge on how to isolate these things in an emergency scenario for them to even begin to do it. But a simple, well-marked AC isolator for the PV system, somebody can come along and quickly, they're all off, that's off, and that shut the whole thing down. No power through the strings. I think it makes sense. Let me know what you think in the comments on that one, because it's just something we've tried on here. It made more sense than taking it off a circuit breaker out of the consumer unit. It's still got RCD protection. It's on a 32 amp rated breaker. It's a 6mm cable. The power supplies, I'll show you when we've got the Tigo Connect. It's not here yet, so I can't show you. Drops it down to a DC voltage to feed into the router or receiver, whatever we're going to call it. We do have an enclosure with DC and AC within it, but all of the cables are rated for the voltages present, and they're still well divided. We've got the DC at the bottom. I made an effort to bring those in lower down, and the AC comes in at the top, and they will be separated by a good distance inside here. So there shouldn't be a problem. Anybody coming to work in that, again, you can isolate all of the power going into that box from there for whatever it is you're doing. The DC isolators, again, they allow maintenance of the SPDs and also of the inverter. So the strings come off the roof into these first. You can see they're going to go in the top of these. If those DC isolators are off, there is no power through into this enclosure in a DC side and no power through to the inverter as well. So if somebody needs to swap that, we've got isolation points in the fixed wiring. I know some people will bring the strings down into the SPDs and then loop out, but you still find it difficult to isolate those in that situation. And that isolation point is in the fixed wiring as it should be. I know there's a discussion around these actually isolating the strings, so you can pull them off and the voltage will still be present, but they're not running essentially, and you can do them in a way that you're not really exposed to the live ends of the terminals. However, if these are weathered, if they've been in a few years, we're talking 5 years before the next active maintenance, they might come apart. They may not have been installed correctly in the first place. It's asking a lot of the person coming along to do maintenance on this in the future if they've not got a point of isolation. And these aren't dangerous, they just need wiring up correctly. So again, we've got ferrules on the end of these, nicely in the terminals, torqued down. These are the IMO variety, so they're super safe. You don't need to put the linking bars in either to break these. You can if you want, so if you've got one of the 4-pole ones that you want to use the one string in, you can still put those buzz bar links in if you wanted, but you don't have to with the IMO breakers. And we always isolate our strings individually. I know you can have one isolator that is 4-pole, bring both these strings in and it would do them together. But the thinking was if there's a fault on a array and the customer still wants to keep generating and using the system while that's corrected, they can do. And I say a golf ball hits them or whatever, or a meteorite, who knows. You don't have to shut the whole thing down while that is fixed, basically. Document holder down there, nice little touch I think with our little logos on everything. So you can see they're all there with our website and details. Same on the GivEnergy All-in-One and on the gateway. And this gateway will keep the power running when the grid drops. So if the grid cuts out, the battery will still feed into all of this with the solar PV as well actually, and the loads can be made use of it. There is an update you have to get GrowWatt to do for it to be compatible. Just got a helicopter going over, so I'll pause a second. So the phone rang, I couldn't remember what I was saying, and I put the isolator covers on. Yeah, DC isolators, very important, changing equipment. AC isolators, and again, trying to set up in a way that works with the Tigo Connect. The gateway, we've got the Proteus RCBO in here as well, just to mention for the EV charger. Bidirectional Type A 30 milliamp, doesn't need to be bidirectional with the EV, but a whole range of Proteus RCBOs have been bidirectional since the very start, so it ticks the box if you are using them. So all we've got left for the gateway is to drop the load consumer unit tails in and make the final connections. That will be tomorrow. Hopefully the Tigo, however you want to say it, tap and receiver turns up, the little router, and I can get those wired in. And otherwise, we're kind of there. I think it looks pretty good. We've got our backing board on again, just to try and keep it neat and tidy. I've got the wipes ready, so we can give it all a clean down. I've got a real sore throat, full of cold the last 3 or 4, maybe 5 days actually, so not feeling the greatest, so excuse the audio if it's not sounding fantastic. We've got the GivEnergy system as always. This is 13.5 kilowatt hours of storage, and it will output and input continuously at 6 kilowatts, and it will also peak to 7.2, so it's an absolute beast, and it's 100% depth of discharge at that 13.5 kilowatts. It will keep the system running in off-grid, and that's just reminding me what we was talking about with the grow watt inverter, where you do need to make sure you make those changes so it will keep running off-grid. It detects a fault, I think it's in the frequency or something that happens when it changes over to island mode. There's a little blip there that it doesn't like, and it shuts down and won't restart until somebody comes and interacts with it. But there is an update that the grow watt technical team can do if you ring them and ask them, which stops that from happening. And the same with the Solax systems, which we have used Solax inverters on these as well. Those don't seem as particular, but there are still some settings that can be changed by their technical team just to ensure it doesn't happen there as well. I think it's something when the grid drops away, this has to allow a cycle or two before it allows the power to flow back into the household, and something happens in that period that some inverters don't like, so you need to watch out for that one. With this particular setup, we shouldn't have a problem, and yeah, we should all be good to go really. I'll show you it when we've got it a bit further down the road. So you can see the existing board looks reasonable, to be fair. We've got the power isolated now, so we can drop these tails out, and we're going to pop our load tails in from the gateway just down below. It's here, tails run up and they come across. We're going to drop them in to this consumer unit here. I'm going to get on with that, put the camera down because I'm on my steps, and I'll show you when we've got it buttoned up, but that's not too bad. It's wired up quite nice. Nice to see a Proteus board as well that's existing. Not our handiwork in this case, and someone has dropped in an MK. We'll see how it fits on the buzz bar. There is the unique mounting of the Proteus system, so it doesn't actually look to have put any strain on the buzz bar. It seems pretty straight, so that's maybe acceptable to leave. Let me know what you think in the comments on that. Not something I really want to go interfering with, to be fair, because it is new work that somebody has done. So that's our new tails in. So we've got the line coming off the load in the gateway, neutral off the gateway, and pop this front cover on and see where we're at. I've been over everything to give it a nice tighten up, and everything seems to be well seated, so we're good to go. So that's the gateway all done. You can see we've got our grid feed coming in. These are still isolated, and the load going out along with the final circuits. If you've watched the channel before, you'll be very familiar with these. That runs up in the trunking, and if you see up here, we have got a tails isolator as well, which is handy for us. So it comes out of the meter into here and then drops down. Thank you, Mr. Meter Man. And we've now got an isolation pre the gateway to wire all that in. The consumer unit of things is all back on, and we can start looking to energize this now. So we need to throw that tails isolator on. I'm going to put the camera down again, get this cover in place, and we'll see if it works. So I've just gone through my dead and live testing, and we're now able to energize this. So we've got the bypass switch on for the minute. The gateway is clunking away. Sorry, the all-in-one is clunking away because it's just firing up. I'm going to have a tidy up of my tools, get the laptop out, and we'll start running through the commission. This is all still isolated. We haven't got the PV breaker on either. They're still working up on the roof. Try and get the guys to get some footage of that. But as you can see, we are nicely in business. So up on the roof, you can see the guys have been very busy. We've got our Vandervolt rail mounted with our hook stops, and we are about ready to go in terms of mounting our panels. This is a flat tile system, so rosemary tiles, and you can see there is a bit of a lump in there. So this roof was redone, I think about a decade ago from speaking to the customer. It's got some new felt inside, but obviously it's an old building and it's got lumps and bumps due to that built into it. And yeah, we're going to have to try and straighten that out through the course of bedding in the panels. And Mike and the guys, I can tell you right now, did a cracking job of just that. The hook stops are used, so if you have any movement on the rail, they're not cracking the tiles underneath. And there is a specific way of fitting these that helps aid in that even more so, which Mike showed us through the course of this project that he'd picked up from the guys at Oval Renewables, in particular Dino. And you can see here again running across the roof, this is a steep one, so we're trying to work as best as we can on this. It's around 49 degrees pitch, so it's a difficult one to walk up and among. But yeah, it's one of those where you want to deliver a really good result because of those challenges, and the guys absolutely revelled in it. Mike, Matthew and Nathan pulled out all the stops, and yeah, you'll wait and see when we get just a little bit further on in this video the end result. PV Ultra up to the array, so we've got 4-core 6mm PV Ultra. I think I bought about 35 meters worth just to give us plenty of slack up in the loft running across to these two dual aspects. And again, Matty did a great job tidying up in there, as you will have seen later on in this clip or already in the video. So if we see the panels down now, these are 440 watts, and that is one leg of those PV Ultra cables that you can see up and out there. And this is the south west and southeast aspects. So right on the corner here is sort of pointing due south, and you can see the guys have left that panel out there. This was my contribution up on the roof with Spencer, who'd popped along from Electrical OM just to get the PV Ultra out. Those panels are in there now. We did have a bit of discolouring that was noted from the garden on the panels, and it was just due to the rain we'd had. So some of these panels had been out on the scaffold and had the coating already kind of washed off, and some of the other ones had been left down under the scaffold and not had it washed off. And when we popped them up, there was a noticeable difference that had us scratching our heads for a little bit. You know, we often notice this when we're fitting arrays, that there are slight differences in the coloration of them until they've been generating for a little bit or had a bit of a wash off from the rain. But this seemed on the extreme side of that, to the point we swapped the panel and then we realised it hadn't fixed it. It's one of those where you learn through trial and error sometimes, and yeah, literally 5 or 6 hours later, all of them looked exactly the same once they'd had that time frame. So you can see the guys there have still got that panel loosened up. It's not currently fixed down into position, and we'll come back to that and show you in a second how they got these level. Nathan is just busy trimming the rail there, so you can see he's using his bandsaw. I think that's the M18 version, and it just goes through it like absolute butter, and then we can pop those end clamps on and get the bird guard down. That is Mike's sucky cup, and that is an absolute beast. So here you can see over on the other aspect, again, we have got 4 panels on the one side and a couple just the other side of the chimney. That was trying to keep the 500mm gap off that chimney all the way around. And there you can see the array flat. So that lump that was there, the guys have managed to pull out with the rails and ensure we've got a nice looking outlook for the customer. The roof looks better than it did before we started, which is one of the aims. The bird guard on there with the mesh, so we've shaped that around as always to try and stop those pesky pigeons from finding a way under there. And I think that's about, we're the happiest doing it like that. I know there's the Van der Valk stuff you can clip in, there's cutting the mesh tight to the actual roof surface, but I think to give the best prospect of keeping squirrels and pigeons out and it looking nice, that is the best way. And again, with the Van der Valk fixings all down nice and tight onto the roof surface, so that is going absolutely nowhere. It was a consideration due to the pitch. It's going to have a fair bit of exposure to the elements at 49 degrees, so we've got some extra hooks in there, and we've made sure that is absolutely rock solid. 3 high in portrait up to the top. We have got 12 panels on that south-west facing roof and 6 panels on the southeast facing roof. And the guys have come up trumps as always, trying to keep our distances off the corners there and off the top. So we're 400mm off the top, we're a good 350 off the sides as a minimum. And then as we move down this roof aspect here, more than the case. But we was working around the chimneys. We didn't want to put panels where they were just going to sit behind a chimney non-stop. And equally, we have the rules regarding keeping 500mm away from them where we can. So we've done that off the back of the chimney there that you can see just to the right of this little
4-panel array where we break apart to then pop these two at the end. And again, these are the 440 watt panels, and you can see they're all bird guarded up, looking the absolute business. If we haven't already shown, I will include some clips from down the garden that show this array in all of its glory. But Matthew, Mike and Nathan again have pulled out all the stops to deliver what was a very challenging roof, a great result. So yeah, 49-degree pitch. It was a difficult one to work with due to the lumps and bumps within it, and they have got it duck pond flat on the finished result. And all these panels are now going to generate for years to come, providing the customer with clean, renewable energy. And massive thanks, while I'm talking about that, to the customer for the hot drinks provided through the course of this job. It makes a massive difference, and myself and the guys are super grateful. And you can see there Mike cleaning up in the background. Let's jump down to the garage.
Things have moved on. We've got the PV Ultra up and out. Just need to clip away that last little bit. We have got cable tie bases and some metal ties in. It's just following an existing cable route around. It is what it is. There's a few obstacles. There's loads of pipes and cables out on show all around this garage. But we've made it as neat and tidy as possible. And that is the Doncaster Cables PV Ultra 4-core 6mm. We've got the GivEnergy gateway here, and this is now on and working with the AIO, all commissioned, all happily waiting for the solar PV to be implemented to the system. We're currently switched off for all that because the guys are up on the roof finishing off the last panels, but we should hopefully have that on this afternoon. And I've got the test sets out already. For those of you who don't know, it's Safe September, where we're going through the Super Rod survey results. So that is now closed, and they're working through the data of that response, and hopefully at the end of the month we'll have something for industry to overview of what's been reported back through that. But the idea with Safe September is that you share examples of isolations just to cause a bit of discussion and chat around the topic. To be fair, it's something that I do all year round. However, always get involved in this because why not? And we've got the PV check from TIS here, and this is for testing the arrays when they come on. So you have your IVCK test. If I pop the backlight on, you'll be able to see. Which is basically a multifunction test of the strings. You've then got your earth continuity testing and your insulation resistance testing and the efficiency test. Now the beauty of this thing is with your modules, you can put in what your actual PV modules generate. So you can see here I've got the Jinko 440s with all of their specifications in. It's VOC, VMP, ISC, IMP, the tolerances, and even the gamma, alpha, and whatever the other one is that I don't know what any of that means. But you put it all in, alpha, beta, and gamma, and you're knocked, and all the rest of it all goes in there. And then when you run that efficiency test, it will tell you if your panels are performing as they should based on the weather outside. So you can see you've got Mike running past here from East Renewables doing his stuff. It's raining at the minute, it's very dark. I think we've got about 40 lumen watts per metre squared when we've had it out as a little test. But you can see we've got the Solar 2 here, and that connects into the irradiance meter, which you take up onto your array. It syncs with the test instrument, and then when that comes back to the test instrument's location, it sends in the data, which is time-stamped against what the instrument's recorded, so it can do its calculations and tell you if your panels are performing right. So you've got your clamp meter on here, which sits on the string as well, telling you what's going on, and then you've got your MC4s over here to plug into your string arrays when you're doing your other tests and such. So it will tell you if the system's performing as it should, which I think is a really useful feature. And it's one of the tests we can do on any system. You don't need to worry about damaging your optimizers using SolarEdge or Tigo, and it timestamps it, produces it in a nice little report. You can put it in your handover pack. It says that on Friday, whatever the date, when the weather was exactly this, your array of 8 panels did this, and based on the instrument's calculation of what should be achieved, it will say if that is acceptable or not. Now obviously you could use your generation data from the inverter, you could compare that with an irradiance meter, you could look at all of the data within the solar panel and try and work out yourself if that's right, but it's not collated in a report, it's not backed by a calibrated test instrument, and for me that is an absolutely brilliant function. There is a newer version of this now called the PV Check Plus, and that has the ISO test basically built into it. So it will do fault finding. It goes up to 1500 volts DC as opposed to, I think these are 1000, maybe 600. I think they may be 600 actually, I can't remember. Check the data sheet on that. But it basically combines those two products and increases the voltages. So if you are looking at one of them, ask for the PV Check Plus, and the same with the Solar 2. There is an updated version of that. I've had these around 18 months to 2 years now, and we are on the cusp of buying the updated ones. I've been wanting them for ages. However, we've got to get value from this gear. We haven't had it especially long time. We were in early with the TIS team for the PV check and the ISA test. So we're just running these a little bit longer. And when we get the other crew out there properly, we can invest in another test instrument. But for the minute, making use of those. We've also got this one out. So this is the HT9025, and that's got a colour graphical screen, and we can use that for kind of data logging. So if we're going up to the array, for example, and you've got your adjustable flat mount system, and you want to play about with it and see how the performance is affected, that's a really good way of doing it. So you can go up there, make your little changes, come back to the graphs, see what effect you had. And obviously, proving unit for your AC side of things when you're doing your lock-offs and isolations with DCs as well. The TIS 8000 does both AC and DC measurements. That is an absolute essential tool for anyone who is doing isolations on AC and DC systems. And then my favourite voltage indicator, the TIS 859, and that's because of the retractable tips. Absolutely love that. And if you are going to be at Lex Coventry, I don't know when this video is out, it's probably out after the event actually, but we were there with one of these gateways on a board with all of these isolators, some MC4s, ProJoy as well, rapid shutdown device on that board, and we'll be running through some demonstrations of how you need to carry out an isolation when you have got multiple sources of generation, different earthing systems in different states, and having a chat about some of that, because I find that interesting. So if you are at those shows and you think it's all just about safe isolation, but you want to chat about some solar, come and say hello. I'm happy to have those conversations. I love them. But I better get on with it now. Go see how the guys are getting on with the array. I think they've got the last 2 panels to chuck up, and they're done. And then we can run through and make sure it's all correct and as it should be.
So we can see Matthew's handiwork up in the loft here. We've got the PV Ultra coming in, and we've used cable ties and metal ties to bring this off and away through the loft space to the roofs we're working on. So the one you can see the cable leading towards there is that southwest facing 12 panel array, and Matthew's secured that up nicely and dropped it out through a lap in the felt out onto the roof surface. You would have seen me actually pulling that cable out with Spencer, ready for the guys to use to feed the panels, and would then pop the other pair of cables back into the loft and run them across again with our warning notices and fire fixings all the way across to the other elevation and passing them out again through a lap in the felt. Point of note with that, we've used the hookstop tiles, so you can get special tile flashing kits that allow cables to be brought out onto your arrays. So rather than grinding out and using an oval tube on this one, we have used those, and they are a great solution. So you can see just dropping again through a lap in the felt. You can see a bit of daylight there because the guys have currently got the tiles off, fitting those back, ready for the cables. And yeah, that's neat and tidy, all labelled up, ready to go.
So before I close this up, I thought I'd show you how these are wired. So this is the Tigo CCA, and we've got a data cable that runs up onto the roof to the tap, and the wiring just matches through from those 2 things. So we've got a power cable, which is your plus and your ground here, and then we've got A and B, which is your RS485 comms, and that can then transfer all the wireless data the tap's connecting from the optimizers on the roof back to this, and also send a signal up there that there's power and to keep generating. And if the tap doesn't receive that signal, it shuts the array down. I'll show you quickly on the instructions roughly how it wires. So you've got the power supply here, which is 24 volt DC, and that then feeds into the CCA. On the roof you have your tap, where you've got 10 meters maximum range to the actual optimizers, and then it fires that back through the linked cable to the receiver, which connects to the internet and integrates online as well, so you can get into all the data I've shown on other videos. These are the kind of maps you'll have. If you watch some of the prior content, we've got some of this. I may include it in this video, I may not. But yeah, that's basic principle. Power in, connection up to the tap, all the optimizers connect into that wirelessly. And if you need more taps because you've got a big array, you can link them up. Point of note is if you've only got the one or in the last tap, make sure this resistor goes in between B and A. Otherwise, it won't work. So we've got the elite squad up there. We've got Magic Mike from East Renewables, Matthew and Nathan. I think they're just about to drop down and come and have a drink. I don't know if I can zoom in on this camera. I think I maybe can. Tap and hold to digital zoom. Let's give it a whirl. Oh yeah, we can. Just that far. So it's not especially far. This is a big garden. We've got the 12 Jinkos on the back there, so these are all in one string into the grow watt. It's the maximum number of panels you can put on a string into that. And then we've got 6 down this side, and that is a 49-degree pitch roof. It's on Van der Valk rail and hooks, and we've got the hookstop rubber tiles and flashing kits on there as well. So the roof's actually in very good condition. There is a bit of a hump in it that we've managed to get out through the rails, so it's looking nice and flat up there. The guys have done an incredible job on what was a very challenging roof aspect with that pitch and with the hump in it. It looks the business. We've got 400 off the top. It's hard to tell from ground level, but there is a good space off the top. And we've got a 400 space off the bottom, and there's the bird guard on there, which is the quick connect clips, which I'll show you in the course of this video if I haven't already. Super easy to install, so it's the mesh, you can't even see it from here, it looks invisible. We've got the bird guard on there, so yeah, it looks nice. Just the 6 to pop on the side. You can see the guys have got them stacked up ready, and then that'll be all done and dusted, ready to go. So I popped the sign on here because it's quite a big one and it would just not stick on the front cover nicely of the actual enclosure. But you can see solar PV system, quick with rapid shutdown. To turn rapid shutdown, switch to the off position to shut down the PV system and reduce shock hazard in array when used the Tigo TS4s. So that's your rotary isolator. Here it tells you to wire it in with the same isolator to the inverter. So we've started doing that. Makes sense when you think about it, because if someone comes in and dush, that will shut the array down and leave a safe state. So we're just waiting to get the power supply wired in. I'll be on with that in a sec. I don't know where I've put it actually. So we'll get that done, get the enclosure up, and then the guys should be done up on the roof so we can fire these arrays up, see if this will find all of the optimizers up there and this start generating. We're actually starting to see some sunshine outside, which is incredible because it's been dull, wet and pretty miserable most of this week. And the day we're coming to commissioning and getting this tested is the day we're blessed with some sunshine. So we'll show you a bit of that as well. Okay, so I've been asked a few times about testing on solar PV systems. You'll see I've got my test gear out here, so I thought we'd have a quick run through it. Just to mention, there is AC and DC in here. So we've got the GivEnergy Gateway, which is looking after the battery storage, the house loads, the grid connection, and also the PV. So there's a lot going on in here in terms of isolations and such when you're carrying out work. So we've got our proving unit, we've got our voltage indicators. This one from TIS, the 8000, does AC and DC. And we've got this one here as well, which is the 859, one of my favourites with retractable tips. And we've got the PV check, which is ready to go, doing our testing on the array. So with the array, you can do your IBCK test, which is like your multifunction test of the string. You can do your PE continuity test, your insulation resistance test, and the one I really like, the efficiency test. So you can see how your array is actually performing based on the set criteria of the panels. We'll have a look at that in just a sec. So focusing on the solar testing, we've got our clamp, which is the HT4004, and just to say there's a superseded version of all of these bits of equipment. There's the PV Check Pro or Plus, I think it's called, which has the isotest functions built into it. And my Solar 2 here, there's a new version of these as well, which is a lot better. I need to get upgraded, but for the minute I'm using these. They were a good investment around a year or two ago, so we need to get some lifespan out of them before I upgrade as much as I really want to, because the new ones look amazing. But yeah, we've got these on here so we can clamp what's going through the string when we're doing our efficiency test. We've got our MC4 leads just behind here so we can plug those in. You may be able to hear the guys are still on the roof just installing the panels, so the string's not been finished yet. I'm just prepping, so I'm ready to go and get that done as swiftly as possible once we're in a position to do so. This is another clamp meter, so this is the HT9025 colour screen, really detailed and very useful for logging as well. So you can log both AC and DC, you can view it later on a PC. It's even got a colour screen that shows you everything that's going on. That's handy if you're jumping out to the roof and making an adjustment or a tweak, you can see what that effect has been. So you do have that functionality in there as a really quick reference point. So yeah, I just thought I'd show you that, the Safer September campaign that's out there right now. I'll be at the Elect show where we've got one of these gateways on a stand with the rotary isolators and such of both AC and DC varieties. We've got some SPDs, earth rods. It's all on there, and we can run through some of the challenges of carrying out isolations, using some of the gear. We'll have all the locks as well, which are in my bag down there. So there's another full bag of all the other bits and pieces for earth stick testing, normal AC testing, EV testing. All of that good stuff is in there as well, with the lock-off toggles and padlocks. So if you are going to be at Lex next week and you do want to hear a bit more about how these work and some other chat around solar, I'm there for that too. Come to the safe isolation stand and say hello. Okay, and looking at the PV check, just speaking about the efficiency test, you can put your actual solar panel modules in. So you can see here we've got the Jinko 440s saved into the test instrument already, where you can set the power of them, the VOC, the VMP, your ISC, your IMP, your tolerances, and then you get down to all of the stuff that I don't know what it is, but it has to have that put in as well, your alpha, beta and gamma. And on the data sheets of the solar panels, I think they call that something else, I can't remember what it is, but I put that in a while ago, so I know it's right, and that enables the instrument, based on what the Solar 02 is telling it the irradiance is outside on the actual roof, and the clamp meter for what the array is producing ties in with what the panels should be doing based on how many of them are in the string. Absolutely incredible, and it just gives you an extra reassurance that things are exactly as they should be. And of course we can make those calculations if we use the data from the actual inverter or the GivEnergy system's seeing, and based on an irradiance measurement of how bright it is outside, and try and tie all that together. But this takes seconds, is so easy, and you've got a logged record of it that it saves in the instrument, and then you can produce that as part of your handover pack. Absolutely love it. I think it's just a way to show that you made the effort of checking the performance of what you've installed is exactly as it should be, and you've got a record of it. I better get on with it anyway. I think the guys, they've got 17 panels they're putting up over 2 roof aspects. There's the south roof with 12 and a westish roof with 5. I think that's right. It might be 6 actually on the west roof and 18 panels. So there's a fair few going up there, so they're busy with that. The weather is not the kindest today. It's windy, it's a bit wet, threatening to be wet anyway. So we'll see how it plays out. It's just about workable for the minute. So that is it. Thank you very much for watching. I hope you enjoyed the journey through this installation. We've now got a customer with 7.92 kilowatts of solar panels up on their roof, combined with an 8 kilowatt grow watt inverter, so there is capacity there to potentially increase the arrays on this property. And we do also have the GivEnergy gateway giving whole home backup and blending everything together into one ecosystem alongside the EV charger from GivEnergy as well. The 13.5 kilowatts of storage within the AIO is going to serve this customer brilliantly. Their consumption isn't the highest for a property this side. They are very efficient in their usage, but this will serve them well through the winter months with overnight cheap rate tariffs, where you can fill that battery up for 6-7p a unit or whatever the rates are over this winter, and make use of that through the course of the day. And when we get back round to spring next year, all of that sunshine that falls out of the sky, totally free of charge, can drop into that battery system and the home for them to use, and anything extra on top you can sell back to the grid at the moment today for around 15 or 16 pence a unit, and sometimes higher than that with the saving sessions and such that Octopus and the likes do from time to time. If you've got any questions around this content, please do drop them in below. If you are a consumer and you'd like a proposal from the team here at PowerSonic, please also see our link in the description and get in touch. Otherwise, we'll see you on the next one.